Hello, everyone. Welcome to the Exhibitor track. I'm Hitesh Bambani, a volunteer in the OWASP community, and I'll help moderate this session today. During the next 45 minutes, we'll be listening to Nicholas present Worrisome Web Vulnerability Trends in the Race to Innovation. Now, please submit any questions you have during the session in the Q&A tab, which you will find just to the right of this video in the OWASP platform. And I'll be asking Nicholas your questions the last 10 minutes of this session. Well, please note that the chat function is available for you to leave comments, and that is in the OWASP platform as well. Okay, so today we have Nicholas, who is a principal product program manager with Invicti Security. He has more than 20 years of experience in IT security, with about 10 years of those focusing specifically on web application security. In the past 5 years, Nicholas is leading Acunetics, which is one of the flagship AppSec solutions in Invicti's portfolio. In the Acunetics platform, tries to be the fastest and most reliable web application security scanners for SMEs across all industries. So that being said, Nicholas, please take over.
So thanks, Hitesh. I'll go ahead and share my screen. So this should be the right one. So good morning, good afternoon, everyone, depending on where you're connecting from, and welcome to this presentation. And today we'll be talking about some worrisome vulnerability trends that we're seeing. Every year, the company that I work for, Invicti Security, goes through and crunches a bunch of data that we compile from our online products. We do this for two reasons. One is so that we can improve our systems, and this is sort of done on an ongoing basis. And we tend to look at the data in more detail on a yearly basis to produce this annual Invicti AppSec indicator report. And this report portrays the state of web application security on a year-by-year basis. So today I'll be talking about the report that we have released earlier this year in spring 2022, which covers the data up till the end of last year. So we'll dive into the results in this session today. So short introduction, Hitesh has already done this. My name is Nicholas Sciberras. I'm product manager at Invicti. And well, at Invicti, our mission is to transform how web application security gets done. And we and myself are very passionate about working with our customers and partners to help them truly protect everything and everyone, with a special focus on web applications and web security. So going on to today's agenda, we'll be briefly looking at the report's methodology. And we are going to do this because we want to ensure that we all understand how we get our data. And then we will zoom in on the findings, and unfortunately, we'll be talking about some of the worst security flaws that are still plaguing us and the DevSecOps teams today. And finally, we'll aim to provide you with some insight into what can be done to improve the situation. Well, not all hope is lost. So before we do that, I would like to quickly introduce Invicti. We are a global leader in web application security since 2005, so we have quite a number of years of experience in the field. We help more than 3,000 customers of all sizes and all industries across every geography. And we help them to secure their web applications in development and in production. And I'm saying this because this gives a bit more detail into where we are gathering the data for the report that we'll be looking at today. So let's dive into today's topic. And as I mentioned, we'll start off with reviewing the methodology that we are using to gather the data. As I already mentioned, every year we strive to get a deeper insight into the state of web application security. And we do this by looking at the data with the aim to find out if severe vulnerabilities are actually getting scarcer. And ideally, we start to find less of these as we go along. At least that's our aim. Now, obviously, there are always a high amount of low and medium severity vulnerabilities that we detect. But we tend to focus more on the higher severity vulnerabilities and ignore the lower severity ones for this report. So we'll be looking at the higher severity vulnerabilities in this presentation too. We tend to focus more on the type of vulnerabilities that are or can be exploited in the wild. And when they are exploited, they can lead to costly data breaches. And unfortunately, to answer the question, are severe vulnerabilities getting scarcer? Unfortunately, the short answer is no, as we'll be seeing later on in the presentation. And therefore, the work of security teams and security professionals remains important more than ever. And hopefully, you'll understand why in the presentation. So for this edition of the Invicti AppSec indicator, we leaned on the deeper and richer data set than we usually do. We have analyzed aggregated usage data for almost 1,000 global customers. Our customers, so these customers that we have looked at, have performed more than 23 billion security checks last year alone, and our products have reported over 280,000 direct impact vulnerabilities. The vulnerabilities we are going to look at in these presentations are vulnerabilities that could have serious consequences if exploited by malicious actors, and also thanks to various techniques used to reduce the number of false positives that we have in our products. Our products and like these techniques are used to confirm most of the vulnerabilities being reported on. So that's one technique that we use to reduce false positives, by trying to confirm the existence of these vulnerabilities and not reporting only based on, for example, the version of a particular product that we have detected. So if I recall correctly, our false positive rate when we had checked it was less than 1 in 5,000. So again, that proves that what we are going to talk about today are real issues, and that the data we are going to see is accurate and therefore should be reflecting the state of the world today. So what does this mean? It means that all this information has given us a very holistic view of vulnerability trends from our automated scan results, keeping in mind that these scans have been done across different company sizes and across multiple regions. And we'll dive into the details in a moment. So as part of this analysis, we have uncovered some alarming trends, right? So I've already mentioned this, and we'll be looking at these in more detail. So as a quick intro to start out, what we have done here is pulled together a chart that summarizes our top high severity vulnerabilities and also their trends for the last 4 years. We are covering here between 2018 and 2021. And this 4-year snapshot shows the percentage of customers that encountered at least one vulnerability of the given type. So in other words, we are showing how often we've helped companies automatically discover high severity vulnerabilities shown in the graph, which includes vulnerabilities like remote code execution, cross-site scripting, and other high severity vulnerabilities. And you can see that the figures are hovering around the same number year over year, or increasing slightly. And well, we can definitely say that overall there is no improvement across all the board. One thing to keep in mind is that Invicti has grown in size, and therefore the number of customers that we have helped secure. This is why we are looking at percentages. Having said that, like the vulnerabilities that were detected in 4 years ago, most of these had been fixed. So we are constantly looking at a wave of new vulnerabilities that are detected year over year in this chart. So if we drill down a bit and we just look at the data comparison between the year 2020 and 2021, we can see a lot of the same or nearly no improvement. So most vulnerabilities like remote code execution and server-side request forgery are actually on the rise between 1 to 3% year over year. So this is a bit worrisome. You would think that with all the awareness that companies like Invicti, but also organizations such as OWASP are trying to do and to raise, these type of vulnerabilities would see them diminish. However, our report and our data seems to indicate otherwise. Now, it is important to understand that these trends, as for example, the top offenders like remote code execution and others like SQL injection, typically lead to some pretty serious consequences. So, for example, compromised backend data, hijacked sessions, or forced actions on behalf of users and services, as in the case of cross-site scripting, for example. Now, one of the things that we really focus on is that security teams need to understand is that this is a true risk, and reporting the number of low severity vulnerabilities is not of true value. So that's another reason why we try to stay away from that. And in fact, having a number of low severity vulnerabilities and reporting them as being of higher severity would actually be of negative value. It distracts the team. It confuses the picture of understanding what the true story of the security posture is. And that is one other reason for focusing on higher severity vulnerabilities in the report. So let's zoom in more and look into more detail at the results, and we'll go through this year's top offenders and look at each one in more detail. So the first one in the list, as I would say one would expect, is remote code execution. And to understand why this is top of the pile, you only have to look back a few months and remember the impact that Log4Shell had on businesses around the globe as they scrambled to check whether or not they were vulnerable to remote code execution attack in the widely Log4j library. So we need to keep in mind that remote code execution can have far-reaching consequences, and it really is considered as the ultimate goal of a cyber attacker. And the reason for this is very simple. Having one single remote code execution vulnerability in a production environment is often referred to as a game over, as this puts the system at risk of complete compromise. And here I'm referring not only to the system where the remote code execution vulnerability is found, but it's pretty much the whole surrounding system and the surrounding network. As with remote code execution, you can easily bounce over to other systems. And the problem with this is that, unfortunately, what we have seen in our AppSec indicator report, remote code execution has seen a steady and worrisome increase since 2018. And in fact, it jumped 5% in frequency in the last 3 years, and 3% in between 2020 and 2021. So it's a worrying trend. So moving on, the next vulnerability I would like to talk about is server-side request forgery, or SSRF for short. And SSRF happens when an attacker is able to masquerade as a web application when communicating with other websites. And this might also include other applications or other systems. So how dangerous is this? And probably I must say that SSRF is probably the most type of vulnerability that is not given a lot of importance. However, in reality, this vulnerability is getting more and more dangerous every single day, and many web applications are now relying on implicitly trusted APIs for internal communication. So that means that SSRF attacks can easily be dangerous, and as they can allow attackers to obtain unauthenticated API access via a trusted server. As a quick example, in 2019, a misconfigured web application firewall allowed a guy called Paige Thompson, he was a somewhat troubled individual, to acquire AWS access keys by exploiting an SSRF vulnerability. So Thompson had gained access to data from approximately 106 million Capital One customers in the United States and Canada. And although this incident put the world on high alert, SSRF continues on a steady climb. And we see that it is back up to being found in 15% of organizations in 2021. And that, as I mentioned, probably we need more awareness on server-side request forgery and the impact that it might have on organizations. And I personally feel that this is why we are seeing this vulnerability as so prevalent in the last few years. So moving on to another top offender that has been with us for, I would say, a very good number of years, if I remember correctly, since 2007 or 8, at the time when, and this time I'm talking about SQL injection, at the time when this was discovered, most of the web applications were still using Microsoft Access as their backend database. So SQL injection is a vulnerability that allows malicious actors to modify and or replace queries that an application sends to a database. And so technically speaking, SQL injection is very easy to prevent with modern web languages and frameworks, as these modern frameworks try to force the developers to completely avoid this type of vulnerability. So its persistent presence, as seen from this graph, is a reminder that application security starts with educating developers to correctly and consistently use the available safeguards. And in fact, we have seen instances where developers try to disable this for whatever reason they might have. So we feel this is a worrisome sign that we're seeing so many SQL injection vulnerabilities, and we need to do more about this. So one example of where SQL injection has caused a big amount of problems is in 2019, where an SQL injection vulnerability resulted in the theft of text data of millions of Bulgarian citizens. and the attackers were able to pull records dating back 10 years. And these records were then exposed on underground forums. These included things like full names, income information, personal identifiable identification numbers, social benefits, and more. So yeah, it's once again, this is one of the attacks that should be prevented at all costs. However, I would like us to maybe pause a bit on SQL injection and focus a bit more on it, because as I mentioned before, this vulnerability has been around for quite a while. There has been a lot being done to try and avoid it, mostly because of its consequences. And considering that we are seeing so many high results on SQL injection, we said, okay, let's dig deeper and try to identify why this is happening. And in our data, so when we analyzed our data and we analyzed like where we are finding these type of vulnerabilities, we found that 35% of education institutions and 32% of government organizations, such as the one that we have seen in the Bulgaria example, had found at least one occurrence of an SQL injection vulnerability. And this, we started thinking about this. What does this mean? And the reality of application security is that it is not always about securing the latest and greatest cutting-edge technologies. When we dug deeper into this, we found that most of these web applications were using older legacy code. For most of these organizations, it's a significant expense and a significant effort to try and modernize. And it might also lead to significant risks, because like changing a web application might also mean that some functionality might be lost in the process. So what does this mean for us? It means that we have to secure and keep in mind both legacy and cutting-edge technology using web applications that using cutting-edge technologies. And we have to do this equally well for both types of systems, keeping in mind that at the end of the day, we are not succeeding in our mission unless we help secure everything and everyone that we are able to secure. So once again, these data points, this data leads to the fact that the reason SQL injection continues to be so common is not necessarily that modern applications are not vulnerable to SQL injection, because in reality, that may be, and we have found multiple instances of where this was the case. However, we need to keep in mind that a lot of these type of vulnerabilities boils back to the fact that legacy code and legacy applications still need to be secured and still need to be checked for vulnerabilities. So I think we can move on from SQL injection, and the next vulnerability we have analyzed is local file inclusion, or LFI for short. And this type of vulnerability allows bad actors to trick a web application into exposing or running specific files on the server. So historically, this type of vulnerability, LFI, has been primarily associated with PHP. So their persistence in our reports can safely be correlated to the continued popularity of PHP-based applications and plugins, keeping in mind that a good amount of the internet or the web space is actually being run on WordPress, which is the backend of WordPress is PHP. So what we're seeing here is that after a slight dip in 2019, LFI is back in business. It increased in 2020 and again in 2021. So we're sort of hoping that history will not repeat itself. And I'm saying this because in 2016, there was an attack on a website called Adult Friend Finder. And this type of attack showed us how dangerous the 5 vulnerabilities can be. In this case, the attackers were able to use this exploit to access information for 412 million user accounts. And this included information such as emails, passwords, and confidential data about the relationship status. And not only is this specific breach, we need to keep in mind that whenever there is such a breach, the email addresses and the passwords obtained for these users, you are guaranteed that attackers are going to try and use them on other websites to gain access to user account and additional user information from the other sites. So although LFI might not be high on our list in terms of security, we need to continue paying attention to these type of vulnerabilities, as they can be easily escalated further. So I would like to take a look now at another type of vulnerability, which is OS command injection. And this type of vulnerability, it lets attackers execute system commands through a web application. And it is often overlooked. However, it saw an alarming jump between 2020 and 2021. And many people might see this, and in fact, it's very similar to remote code execution. And the rise in command injection flows may be related to the popularity of modular and containerized deployments, where each service or microservice potentially presents a separate injection target. And that might explain the rise that we are seeing over here. So if you want to know how bad it can be, we just need to look at shell shock, which is a widely known vulnerability that enabled malicious actors to inject OS commands and take control. Within hours of the vulnerability disclosure in 2014, so the attackers were able to exploit the flaw and create a number of computer botnets that performed millions of DDoS worldwide attacks. So once again, it is not how the individual vulnerability has been exploited, but as we're seeing in this case, the vulnerability was escalated to do much more damage than what the individual vulnerability could do. So we move on to another top offender, cross-site scripting. I think when people start in web security, like the first two vulnerabilities that they start learning about would be SQL injection and cross-site scripting. Cross-site scripting is obviously going to feature in our report, as it's still one of the most common flaws in the block. It saw a slight improvement in 2020, going to 65%. However, it bounced back to 71% in 2021. So we see this as a very common web vulnerability. And to give us more explanation, it allows attackers to inject their malicious JavaScript code and execute that in the user's browser. And though considered a low impact vulnerability by many developers, cross-site scripting is dangerous because it can open the way to sensitive data disclosure. And that includes session hijacking, redirecting to malicious sites, malware installation, and possibly other social engineering attacks. So these are make cross-site scripting quite dangerous. So cross-site scripting has made serious waves in the past. A quick example is the 2008 British Airways attack, where it found itself in the media as a cross-site scripting exploit led to a data breach impacting 380,000 booking transactions. And security researchers suspected that the attack was linked to MageCart, which is a hacking group that notoriously uses card skimming techniques and malicious code injections. And well, that was one of the many attacks that that happened using cross-site scripting. I would say that most of the others might go unnoticed because they might be affecting single users. Nonetheless, cross-site scripting is still a very important vulnerability that should not be overlooked. And yes, and as we're seeing here, cross-site scripting is still slipping under the radar, and we're constantly finding this type of vulnerability over and over again. And maybe we'll look at one final vulnerability, which is cross-site request forgery, or CSRF for short. And CSRF is a credentials management flow, and it gives attackers the ability to trick end users into performing unintended operations. Once again, it's one of the oldest web vulnerability classes, and it continues to appear frequently despite well-known server mitigations, although we can expect advances in browser security to slowly make it less prevalent in the coming years, which is somewhat good to hear. So this type of vulnerability is most often conducted through a social engineering attack, such as, for example, via an email or through an altered link. And in this case, instances of CSRF will typically only cause harm to a single user that's being targeted. However, if the attacker targets an executive or a primary administrator, that single user's actions may also escalate to more dire consequences. So this is the reason why we decided to include CSRF in our report. One example would be that the attacker might be able to gain access to an administrative interface of the web application that would only be available to the administrator of the web application, and then potentially escalate the attack to either take over the website or download the entire database. So once again, an important vulnerability to keep in mind. So why do these vulnerabilities keep appearing? We do not seem to be paying close attention to this question, and we'll try to speculate why. So in our focus to shift to the cloud and enabling hybrid workforces for success, it's never been clearer that web application security needs to stay at the top of mind for organizations, small and large. And for those adjusting to this new reality of hybrid remote work, it's not an easy feat. According to the latest ESG research report, 69% of organizations found that difficulties around security hygiene and posture management has increased in the last two years. And as we all know, there is a massive talent shortage in IT security that is contributing to the ongoing problem. Once again, according to ESG, 70% of information security association members cite that cybersecurity skill gap as having an impact on their company. So less security people unfortunately leaves web application not tested enough for these type of vulnerabilities. So in the previous edition of the Invicti AppSec indicator, we fielded a survey focused on the working relationship between security and development teams, and what we can do to make lives easier for both sides of the aisle. And the numbers are staggering. On average, 51% of web developers' time is spent chasing security issues, and 80% of our respondents to the survey noted that security processes delay delivery times somewhat or significantly. We also uncovered that 1 in 3 security issues under remediation make it into production without getting flagged in the test or development stages. So I would say that's quite a bit of information. And that's a big problem and one that can easily hamper innovation if left unchecked and leads to serious security risks that build up as security debt when we are not looking. So this is why we need to constantly be checking our web applications. Ideally, any type of vulnerabilities are detected before the web application goes into production. And having said that, even once it has gone into production, we should continue checking the web application, since there can be things like 0 days, like we've seen, like the log4 shell, which can which cannot be checked before information about the vulnerability is known. And therefore, it's once again, it's important that web applications are checked on a constant basis. So I'm sure all of you would love to know what we can do then and how we do keep vulnerabilities at bay without sacrificing innovation. So how can we win this innovation race? And these worrisome vulnerability trends in our scan data are solvable with the right approach to application security. And here are just some success stories showcasing how modern AppSec tooling has helped enterprises solve some of the battles we have touched on today, and we could not have said it better. So these are customers that that have provided us with some best practices and that we would like to share with you. So although the configuration of an AppSec program varies from organization to organization, there are foundational elements and goals at the core of every company with a healthy security posture. And these include the prioritization, and we usually focus on prioritizing secure design models that cover all the bases, baking security into the pre-code processes behind the application architecture. Of course, this can only be done with the right approaches and with the right training to our developers, to our designers, to pretty much all our DevSecOps operations. One key foundation element is to break down silos between security and development and empower the teams to work cross-functionally on security roadblocks. Unfortunately, we see this very frequently. We often get reports being filed for web applications that are being scanned by the security engineer, and the report would be filed by the administrator of the web application, because he would not have known that the security engineer is running his own tests in the background. So we need to break down these silos, these impediments, and get them to work more closely together. And hopefully they will learn from each other in the process. We would ideally make security a part of every stage of the development of the software development lifecycle. Once again, scanning both production apps and those in development is equally important. Of course, scanning production apps should be done to prevent vulnerabilities from going to production. However, once the web application is in production, that does not mean that it is super secure, because once again, like any new vulnerabilities that are discovered, that would mean that they are immediately available in your production server. And we need to invest in robust tools and automate everything as much as possible, so that we fold and like this automation should be seamless and fold into our existing workflows. And ideally, we should provide and monitor analytics and reporting, which would allow us to monitor success and also monitor for any failures in order to improve on a constant basis. And once again, we should insist on accuracy from the tools that have low false positive rates, and provide clear and actionable guidance for developers. So any tools that we use should not provide generic guidance, but specific guidance on the vulnerability. And once again, here at Invicti, we tend to focus a lot on false positives for the simple reason that they would distract the engineering team, the security team, and they would reduce the impact of our tools. So success in modern application security requires more than just thoughtful and combination of skills and tools. We need to clear top-down initiatives and initiatives that the whole organization can follow. And we also need to keep an eye on trends for what we call direct impact vulnerabilities, such as the vulnerabilities that we have seen earlier on. So yes, these worrisome vulnerability trends that we have seen from our scan data are solvable with the right approach to application security. Having said that, it has to be done on an ongoing basis. And these are just two success stories that we have had, showcasing how modern application security tooling has helped enterprises solve some of the battles we have touched on today. And we could not have said it better. So these are two of our customers that have left us comments that we would like to share with everyone. And that brings me to the end of my presentation. So I'll be happy to address any questions that you might have.
Yes, thank you, Nicholas. A reminder to our attendees that you can ask questions in the Q&A tab, which you'll find on the right of this video. We can give a few seconds for our attendees to submit questions. And while we wait, Nicholas, I was wondering about there was like a huge number of checks that were done, around 23 billion. That's an astounding number. Can you tell us about those scans or checks that you mentioned in one of the earlier slides?
Yes. Just to make things clear, we are talking about 23 billion security checks across all our across all the scans that we have been doing. So each security check is one attempt to find one individual vulnerability in a portion of the web application. Talking to our customers, we see that they integrate our solution into their development pipelines. And also they are scanning the same web application at multiple stages of the application lifecycle. So they tend to test early, and they also tend to test often, and worked with them so that they do this successfully. So if you think that most of our customers are trying to do this, and we help them do this, this translates into thousands of scans. And each scan will run several thousands of security checks, sometimes even more than that, depending on how big the web application is. And some of our customers are scanning hundreds and even thousands of web applications on a regular basis. So this 23 billion is the grand total of all the checks by our customers from our cloud-based solutions. And if you think about it, it's considering all the number of scans that are being done, it looks like a big amount, and it is in fact big. But we're constantly increasing new checks and supporting new technologies, so that number is expected to increase in the future.
Yeah, definitely. Yeah, that's, scan often is good. Then kind of follow up on you mentioned that customers do use it in development and before production. So various, maybe at security gates that they have in their pipeline. And what is the number of the proportion, I'd say, between production issues versus issues early on in the dev cycle? Can you tell us about that?
Yes, that's a bit of it's a bit of an interesting question, because from our perspective, it's a bit difficult to say if the web application that we are scanning is in production or not. Once again, we try to work with our customers to scan as early as possible. So I would say that probably 60 to 70% of the scans would be pre-production. Having said that, we also stress the importance of scanning production web applications. As mentioned in the presentation, these are equally important, as new vulnerabilities are always being discovered and are always being implemented inside our solution. So keeping abreast of any new security trends is best, and these should be applied to both pre-production and also production systems.
Yep. Thank you. And let me check if we have any questions there. All right, so while we wait for any audience questions, there's I do keep hearing that browsers, they're always trying to have security improvements and try to eliminate some of the things that are issues on the browser side, like cross-site scripting, cross-site request forgery. Do you see any of that improvement, or how do we try and reduce that from the browser's side?
Well, talking about CSRF specifically, we are definitely expecting it to get less and less common in the next few years. There are already known and tested ways to avoid CSRF, like anti-CSRF tokens, same-site cookies, and there is good browser support for them. But this also has to be done on the application side, and it needs to be done correctly so it really works. So it will really keep finding some CSRF caused by errors in the implementation of these protections. We already see this nowadays, and we expect to continue seeing this in the next few years. However, CSRF, from what we can see, it should be going down soon. With cross-site scripting, it's really a race between new ways of injecting JavaScript into a site and ways of detecting and preventing it. So you might probably remember these cross-site scripting filters that were getting built into the browsers, and these started like a few years back, and now the browser vendors have dropped them completely because they are deemed to be not as effective. They can only stop a fraction of the many cross-site scripting possible attacks, and this was somewhat causing a false sense of security and possibly making developers be a bit more sloppy in how they try to detect and prevent these. So the flip side is that the attitude that developers don't need to worry about cross-site scripting because the browser will stop it. That's going to change. Now every web application uses JavaScript. So as long as we keep getting unsanitized user inputs in applications, people are going to find new ways to get JavaScript to be executed by the web application in order to perform cross-site scripting. So in this case, in the long run, there's likely to be more use of frameworks that limit the risk. However, cross-site scripting, the way that we see it in some way or form, is likely here to stay, even with all the work that's being done from the framework side to limit the risk.
Okay, yeah, interesting. I wasn't aware that some of these checks had been actually dropped by the browsers. So yes, that is concerning and all the more important for developers to uh, understand of the basic security needs and then code it. Yeah. Okay. All right. I think that brings us to our session for today. Thank you so much, Nicholas. That was very insightful. Um, and
Thanks,
then,
thanks, Hitesh. Thanks
yeah,
for getting me here.